I'm Aiden Murphy.
And I'm Luke Van Houten.
And this is our project about predicting the Cy Young Award voting based on MLB pitching statistics.
So our motivation for this project is that we're both really interested in baseball stats. We want to look at predicting some sort of baseball stat, specifically in pitching as opposed to batting. We found there's a lot more complexity with pitching statistics. And the Cy Young Award is the award given to whoever baseball writers feel is the best pitcher in MLB at the end of the season. And trying to predict these votes for these awards and seeing how they correlate to different pitching stats fits with our interest in pitching in baseball.
And for some context, pitching in baseball is when the pitcher throws the ball to the batter, trying to get the batter out while the batter tries to hit the ball. Starting pitchers start the game and usually pitch about 6 to 7 innings, and then relief pitchers come in the end, pitching 1 to 2 innings apiece to finish out the game. And then the Cy Young Award is an award given at the end of the year and is decided by whichever pitcher gets the most Cy Young votes. And then the votes are given on 1 to 5, with first place getting 7 points on a ballot and fifth place getting 1 point on a ballot.
So our research questions are, first, how can we predict how many vote points a top tier pitcher will receive for the Cy Young Award based on their stats? Second, how have the development of new stats and ways of thinking about the sport changed the factors that determine the amount of votes that top tier players receive for the award? And finally, how can we determine different pitching statistics thresholds that gain award votes for relief pitchers as opposed to starting pitchers?
For research question 1, we combine data from FanGraphs and Cy Young Award voting data. From FanGraphs, we took pitching data such as WAR, wins, ERA, FIP, WHIP, among other statistics, and then combined those with Cy Young Award voting point totals. Then we split the data into 20% trained test splits and loaded those splits into the XGBoost model, random forest model, and decision tree models to predict the voting total.
So for the research question 2, for the arrows, we first split the data to be before 1990 and then 1990 and after. We found the 90s are a decade when a lot of new pitching statistics such as WAR and just new repositories were created, and a lot of thinking about baseball changed in that time. So we ran linear regression models on each of the 10 features discussed previously to see how they correlate with Cy Young Award vote points. And then we did this for both eras to see if that different ways of thinking really changed. And we also looked at it visually, but also looking at regression stats such as the correlation coefficients and R squared between these eras.
And for the third research question, we used a very similar research method as the previous question, but just split between starters and relievers rather than eras.
So for the results for our first question, the models, we found the XGBoost model was the most accurate with a mean absolute error of around 35. WAR followed by wins were the most important features. And this was similar for the other models too, but I'll get into the feature importance on the next slide. The random forest was next with about a 36 MAE. And then finally, the decision tree was last place with a 42 MAE. So you can see here that on the XGBoost and random forest, the wins and WAR were both at the top, with WAR coming in first on XGBoost and then swapping the two between wins and WAR on random forest. Whereas the other stats all had some, they were important as well. But on the decision tree, only wins and WAR had any importance, and everything else was pretty useless for the model. And combine that with the worst era, we see that the decision tree model wasn't that good compared to XGBoost or random forest. So then our results for our second and third research question, with the eras, we found no real difference between these eras. We thought that wins, considered a lackluster and not that good of a stat nowadays, would be less important now than then. But we found that pitchers are usually good based on other stats. They probably have a lot of wins as well. For the third research question, we found a very substantial difference between starters and relievers. Starters have much more correlation between their stats, whereas relievers suffer from less data, less playing time, and less special stats. So say a starting pitcher gets a 2 ERA, that's really good. But if a relief pitcher gets the same ERA, it might not be as special as a lot of relief pitchers in general have lower ERAs, such as those around 2. So you can see here in the visualization of all of these with the error comparison, there's really no difference between the top 2 rows and the bottom 2 rows for these different eras. But then on the pitcher type, the starting pitchers have a lot more data, a lot stronger correlations, whereas the relief pitchers just have less data and less correlations. So for key takeaways, we found that winning is really important. Wins over replacement WAR provides the most comprehensive quantification of winning for individual players, so it being important makes the most sense. And then despite having a bunch of criticism for it being more of a team statistic, wins in general are still really important. And really, we found that the thinking about these stats hasn't necessarily changed a ton over time when compared to how voting actually is done. And then finally, relief pitchers contribute less to winning games, so they're more often overlooked. Saves is a stat we didn't look at that acts like wins for relievers.
And for future work, we can improve our machine learning models in question 1 by looking more about how it makes the predictions and some more hyperparameter tuning. And for these models, we only really looked at feature importance and error as opposed to some of the raw predictions. And then for questions 2 and 3, we only used linear regression. And perhaps some of the data would have changed if we used different methods instead of linear regression. Finally, we could add saves for relievers, and that could make a change in the data. And we can add some raw pitching data, such as velocity and pitch movement for the different pitches. Thank you for watching our presentation.